Waves, Part 2. The objectives of this lesson is to describe the features of a wave in terms of wavefront, wavelength, frequency, crest, trough, amplitude, and wave speed. And to recall the equation for wave speed, V is F times lambda. What we're going to look at firstly is the different words. Amplitude, which means physical extent, which is the total distance from the undisturbed position. Crest, which means the top, which is the highest point of the wave. Trough, which means hollow, which is the lowest point of the wave. And wavefront, an imaginary surface we draw to represent the vibrating part of a wave. If we look at this simulation, we see a dripping tap into water. Now, the water is disturbed, and that's what we call a wave or an oscillation, a disturbance of the medium, as previously discussed. So the amplitude is how high the waves are. If I increase the amplitude, I see that the waves are higher and lower. So the waves move further apart, a greater disturbance of the medium. So the amplitude is how far it is from the original position. Now if we turn off the tap, we see what is the original height, and the distance from that height to the maximum minimum point is called the amplitude. Now the second two parts that we want to speak about the highest point, which we call a crest, and the lowest point, which we call a trough. And last but not least, if we look from the top, we see the waves, and I think another simulation would work better. We see the waves moving from the top. And if we look at it three-dimensionally, we see the water dripping and the waves spreading out. So we can see here at the furthest point, all these lines represent a wavefront. We can see how the wave moves closer and closer and closer to us. And if we look from the top, we see that there is dark lines and light lines. Okay, the dark lines represent the tops, the crests, and the light lines represent the troughs. And as we look at the 3D view, we see the waves approaching us. So let's see again the waves coming towards us, and that circular thing on the outside spreading out is called a wave front. The next part we're going to look at is what is the wave speed. It is the speed at which the wave moves. The wave length, the distance between two peaks of a wave, or the distance between any two points experiencing the same motion at the same time. Frequency, which means crowd or multitude, how crowded the waves are, or the amount of waves passing per second by a point. And period, the recurrence, the time per wave passing by a point. Now to understand wave speed, I'm going to show you this equation or this simulation. If we look at the pulse that I'm creating, we can see that it takes a certain amount of time for the pulse to reach the window. So if we measure that time, I'm going to start the timer. If we measure that pulse and how long it takes to reach there and exit the window, that is the amount of time, and we see that the distance here is like 7 centimeters. So we know that we can calculate speed is equal to distance over time, but usually we do not have the luxury of rulers and timers when we're measuring waves. So what we do here is we have to find another way of calculating the speed. So firstly, just want to show you guys again, here is the amplitude. I can make the amplitude higher, or I can make the amplitude lower. Okay, so just showing you that. Back to our way to calculate, we now must be able to calculate the wave speed in another way. So if I pause it over here, we see that we have particles moving up and down. Now the distance that we have from one particle to another, let's say from the crest to crest here is 4 centimeters, 4.2. Now that distance is called the wavelength, the distance from one crest to another. Or we can say a wavelength is from a trough to another trough, or basically any 2 points experiencing the same motion at the same time. So what we need to know the wavelength, and that we measure with a measuring device. So we can see here that from the starting point to this point is just, let's say, 4.1 centimeters. And here at the bottom we see the frequency, how frequent they are, is 1.5 hertz. Now if we take those two, we can use those values to calculate the speed of the wave. If I increase the frequency, we'll see that the waves move more frequently. So I see more, and we understand the word crowded. Okay? If there's a lower frequency, we see that it's less crowded. Okay? So the word crowdedness here is the frequency. And we can see that if I increase the frequency, the wavelength is shorter. Now in this case, the wavelength is about 2, where previously the wavelength was 4. So to calculate the speed at which the wave moves, we can take the frequency and we can multiply it by the wavelength. And this will guide us to our formula, which says wave speed is frequency times wavelength. Thank you very much. I hope you have understood this lesson, and if you have any questions, please let me know. Thank you.